Hello, welcome to day 8 of Jamb Mathematics in 30 days. I must say it has been a wonderful series so far, and a big thank you to each and every one of you that has been on the series from day 1 up until this point. I want to believe that we are improving day by day because that's our motto, that by the end of this 30 days, you should be able to ace Jamb Mathematics. Now, for those of you who are seeing this video for the very first time, yes, this is a 30-day series to help you prepare well and ace Jamb Mathematics. Now you can go ahead to check on the videos from day 1 up until this present day 8. I promise you, if you follow this religiously, all you have to do is just dedicate 30 minutes to 45 minutes of your time daily, and you are building your mathematics, and you should go ahead to get a very high score in Jamb Mathematics. Now, day 8 is all about progression. Now, in general mathematics, we learn about different kinds of progression. The common one is the arithmetic progression and geometric progression. Now, we have a video on our channel here where we have explained progression in details. You can find that video tagged sequence and series. Now, when you go over it, you should be able to get every knowledge there is on sequence and series and all the types of progression that we have, including all the calculations that you can find on those topics. But as far as Jamb is concerned, these are the objectives, the part of this topic that you are expected to be able to master before you take the exam. Now, the first thing that Jamb expects you to do is to be able to determine the nth term of a progression, and then you should also be able to compute the sum of AP and GP. That is when they give you a certain arithmetic progression or a certain geometric progression. That's what AP and GP stand for. Arithmetic progression, geometric progression. When you're given any one of those, you should be able to compute the sum, right? And then you should also be able to compute the sum to infinity of a given geometric progression. Once again, please, if you haven't subscribed to the channel and also click the notification bell, this helps us to be able to produce even more meaningful content like this to help you grow. Now, let's go on to solve some questions on progression. Now, here is a question from Jamb 1999 on progression. The question says that the first term of a geometric progression is twice the common ratio. Find the sum of the first two terms of the GP if the sum to infinity is 8. Now, in order to solve this, let's establish some facts. When you're working with geometric progression, it has a first term A. And now we are told that the first term A is twice the common ratio. Now, common ratio is denoted R, so A will be twice of R, right? And we also know that common ratio R is supposed to be second term, so let's call that N2 over first term A, right? Now, if we continue from here, we can then say N2 over, now A is 2R. So from here, we can make N2 the subject and say second term would be twice of R squared. Now, there's also the regular formula we can use to find the particular term in an AP, which also goes in the same direction. Now, if we're working with this, we can then go on to find this problem. Now, one more thing that we need to know is that when you're working with sum to infinity, the formula there says that S to infinity is given by A over 1 minus R. And since we already know what A is, we'll then go on to say A is, now remember, twice of R over 1 minus R. Now let's put this so that we can solve for R. Now the sum to infinity is given as 8. So 8 equals 2R over 1 minus R. And then when we cross multiply, we would have 8 into 1 minus R equals 2R. And this means we'll have 8 minus 8R equals 2R. Now collecting like terms, 8 equals, now this coming here will become plus 8R. Now plus 8r plus 2r will give us 10r, which implies that r is 8 over 10, which is the same thing as 4 over 5. Now from here we can then find the first term. A would be twice of r, which is 4 over 5. So A will be 8 over 5. While N2 would be twice of r squared. So 4 over 5 squared. So we have 2 here. This will be 2 multiplied by 4 squared is 16 over 5 squared, that's 25. And this will give us 32 over 25. So now we have the first term and the second term. And we are asked to find the sum of the first two terms. So what we are asked to find is the sum of A and N2. So we say 8 over 5 plus 32 over 25. This would give us, now LCM here is 25. Now 5 in 25 is 5. 5 times 8 will give us 40. Plus 25 here 1 times 32 remains 32. Now when we add this up, we have 72 over 25. So from what we have solved here, we can see that the correct answer is option C. This question says the third term of an arithmetic progression AP is 4x minus 2y. And the ninth term is 10x minus 8y. So find the common difference. Now, when working with arithmetic progressions, now we know that the nth term of an AP is given by the first term A plus the term, as in the number of the term, whether it's the third term, fourth term, fifth term, whatever the term is, n, and then minus 1, then multiplied by the common difference D. So once we have this, we can then go on to use the information we have here to go on to find the common difference. So let's start with the ninth term. We are told that the ninth term is 10x minus 8y. So the term will be for T9. That is 10x minus 8y will equal the first term. We don't know that, so we still leave it as A, plus, now this is the ninth term, so that will be 9 minus 1, close bracket D. Now if we tidy this up, we would have 10x minus 8y equals A plus 8D. Now applying the same thing for the third term, we're going to have now the third term, T3. That will be given by, now the third term itself is 4x minus 2y. Okay? And this equals the first term as well, following the same formula. Now, since it's the third term, n will be 3. So 3 minus 1, that's 2. So plus 2, and then D. Now, what we have to do here, we see that we have two equations, like so. So we can then go on to subtract equation 2 from equation 1. So if I subtract like this, it means I'll have 10x minus 4x. That will give me 6x. Now, minus 8y minus 2y. Now, minus times minus becomes plus. So that's minus 8y plus 2y. And that will give us minus 6y. Equals a minus a, that's 0. So 8d minus 2d will give us 6d. Now, if you look here, they have 6 in common. So we go on to say 6 into x minus y equals 6d. Now, divide both sides by 6. And then we can conclude by saying d equals x minus y. Since 6 will cancel 6 in both places. So now we see that the common difference is x minus y, leaving our correct answer as option C. Now this question is also similar to the last one we solved, but this time we are given the fifth term of an AP as well as the 11th term. So the fifth term is given as 24 and the 11th term is given as 96. So now we have to find the first term. So in order to find the first term, in the previous one it was common difference that we're checking for. This time we need first term. So in order to find the first term, we'll go around the same route. We already know that the nth term of an AP is given as the first term plus number of term minus 1, then common difference. So since this formula is established, we can then go on to apply it to the 11th term and the 5th term. So for the 11th term, n will be 11. So and the 11th term is given as 96. So this is T11, right? So 96 equals the first term, which we don't know. This is what we are looking for, by the way. So plus n would be 11, and 11 minus 1 will give us 10. So D. Call this equation 1. Now apply the same thing to 5th term. So T5. Now the 5th term is given as 24. So 24 equals first term plus, now n is 5. So 5 minus 1 will give us 4. So 4D. Call this equation 2. We can go by this name to get D first. So we subtract equation 2 from equation 1. Now 96 minus 24, this will give us 2 here and 7. So we have 72 equals, now A minus A is 0, while 10D minus 4D will give us 6D. Now dividing both sides by 6, we find that D equals, now 6 will go in 72 12 times. So the common difference is 12. Now let's find A. So we can apply D, substitute D into any of these equations. So let's substitute into equation 2. In equation 2, we have that 24 equals A plus 4. Now D is 12. So we can then say 24 equals A plus. Now 4 times 12 is going to give us 4 times 12, that's 48. Now, A would then be 24 minus 48. And this will give us negative 24. So the correct answer is in option D. Now, this question from Jamb 2009 says, the sum of the first n terms of the AP 5, 11, 17, 23, 29, 35, and so on is... So we have to find the sum of the first n terms. Now take note, we don't know the number of terms that is involved in what we are looking for here. So it's the sum of the number of n terms. So that's why you see that in the options we only have equations. We have expressions rather in the options that is provided. Now in order to solve this, here are some things we need to establish. Now the equation for the sum of n terms in an AP is given as sum of n equals n over 2 into 2a plus n minus 1d. Now, working with this, we can see that from this AP we are given, the first term A is 5, and the common difference D is, now when we find the difference, 11 minus 5 would give us 6, just as 17 minus 11 will also give us 6. So common difference is 6. Now we plug this into the equation and then we should get an answer. Now, n is unknown, so n over 2 into 2 multiplied by A, which is 5, plus n minus 1, and then D is 6. Now working with this, we can then get n over 2 into 10 plus n minus 1, and then 6. Now, these two can then go into this part here so that we just have n here. And then here we have 10 over 2 plus n minus 1, 6 divided by 2 as well. Now, when we do this, we have n into, now 10 divided by 2 is 5 plus, now 2 here 1, 2 here 3. So we would have this as n minus 1 and then 3. Now, there seems to be nothing in common here, so we just have to expand this part now. So when we expand this part, we would have n into 5 plus, now what we have here is going to be 3n minus 3. Now let's open this up. So n would then be 5 plus 3n minus 3. And then we have n into 5 minus 3 will give us 2 plus 3n. Now we can then rearrange it, because if you see in your option we have n placed in here first. So we'll have n into, then we write 3n plus 2. So, and this is exactly what we have in option B. So our answer would be B. Now, let's solve this question from Jamb 2009. Find to infinity the sum of the sequence. Now we have 1, 9 over 10, 9 over 10 squared, 9 over 10 cubed, and so on like that. Now please, if you are here to subscribe, please do so, and also hit the notification bell, as it helps us to continue to give you more contents like this that are helpful. And also tell as many to join the challenge. Now, as we go to solve this question, now take note of this. In this question here, we can see that the numbers are increasing in a geometric proportion, right? So, and the first term here is 1. Now, we also need a common ratio. Now, common ratio is either your second term divided by first term, or third term divided by second term, and so on. You can also do fourth term divided by third term as well, please. So I'm going to do these two so that you can see that they are going to give you the same thing. Now, if we do second term divided by first term, we'll have 9 over 10 divided by 1. And this would give us 9 over 10. Or if you go the other route, where we have 9 over 10 squared divided by 9 over 10. You know, this is like saying power of 1. Now, when you divide, indices say you should subtract the power. So, and that will give us 1. So, we'll have 9 over 10 as well. So, the common ratio is 9 over 10. That is established. Now, sum to infinity of a GP is given as first term divided by 1 minus r. Now, when working with this, now we already know the first term to be 1. So, we'll put that down. 1 all over 1 minus. Common ratio is 9 over 10. So, this is what we have to tidy up. So, we have our sum to infinity now being 1 over. Now, for the denominator, they have, no, this can be written as 1 over 1. So, LCM is 10. 1 in 10 is 10. 10 times 1 would have 10 minus 9. So, this is basically having 1 divided by, now this will give us 1 over 10. So, therefore, we can then say that our sum to infinity is, now when we change this to the multiplication sign, we will flip it. So, it will be 1 times 10 over 1. And 1 times 10 over 1 will give you 10. So, the sum to infinity is 10. So, the correct option is A. Now, this question says the third term of an AP is negative 9. And the seventh term, now take note, this is 7. So, seventh term is minus 29. Find the 10th term of the progression. Now, We recall that the equation to find the nth term of an AP is given as A plus n minus 1 D, right? So we're going to apply this and then use it to get A and D using the information we have for the third term and the ninth term. So once we have A and D, then we can then solve for the 10th term. So let's start to get common difference first. So I'm going to use let's use the seventh term first. In the case of the seventh term, we have negative 29 as the term equals A. We don't know the first term, so plus. Now, because it's the seventh term, n will be 7 there. So 7 minus 1 will give us 6. So 6D. Call this equation 1. And then applying the same thing for the third term, where n will be 3. The third term is negative 9. And this equals A as well plus. Now, third term means n minus 1, 3 minus 1 to give us 2. So we have 2D. This is equation 2. Now, all we have to do is subtract at this point. Now, when we do the subtraction, minus times minus here gives us plus. And 29 minus 29 plus 9 would give us minus 20 in this case. So we have negative 20 equals A minus A is 0. So 6D minus 2D, that is 4D, right? And what this implies is that D is negative 20 over 4. And this will give us negative 5. Okay? Now that we have the common difference, let's go on to find the first term. Now you can plug it into any of the equations that we have, equation 1 or equation 2. Please do not put this minus when you are doing that. So in this case, if I'm using equation 2, it implies that negative 9 equals A plus 2 into minus 5. And what this implies is that A is, now 2 times minus 5 will give us minus 10. And when we take minus 10 to the other side, it becomes plus 10. And then we have minus 9. So A equals 1. Now let's find the 10th term. So T10 would therefore be A, which is 1, plus. Now we have n minus 1, where n is 10. So 10 minus 1 will give us 9. And common difference is minus 5. So this would give us 1 plus minus 45. So T10 would therefore be 1 minus 45, which is negative 44. So from the options provided, the correct one is A. Now, in this question from Jamb 2010, we have to find the sum to infinity of this series. Now, sum to infinity is given by 1 over 1 minus r. So A, rather, all over 1 minus r. So, and we are given that A here is 0.5. And then we can get the value of r by saying 0.05 divided by 0.5. Or we can go 0.005 divided by 0.05. It's still going to be the same thing, which is 1 over 10. And 1 over 10 is the same thing as saying 0.1, but I just like to work in fractions, so let's go on. And by the way, you can see that the options we have here are in fractions, so it's a hint that working in fractions will help you arrive at your answer faster and without error. Now, working with this, we can then say sum to infinity is A is 0.5, so I can write 0.5 as 1 over 2 divided by 1 minus 1 over 10. So basically what this means is I'm going to be having 1 over 2 all divided by, now if we take here LCM is 10. This is like saying over 1. So 1 here is 10. 10 times this will become 10. So minus 1. So what we have there is that our sum to infinity becomes 1 over 2 divided by, now 10 minus 1 is 9. And then this is 10. So we can rewrite this and then say 1 over 2 times, when we flip this, we would have 10 over 9. So 2 here 1, 2 here 5. 1 times 5 is 5. 1 times 9 is 9. So our answer is 5 over 9. That's in option D. Now, in this question, we're asked to find the nth term of the sequence. So we are basically looking for an equation that describes the nth term of this sequence, where we have the first term as 2, second term as 6, third term as 12, and then the fourth term as 20, and then it continues like that. Now, if you test this using your knowledge of AP, you see that it is not an arithmetic progression, because if you check the difference between 2 and 6, you have a difference of 4, whereas the difference between 6 and 12 is 6. So it's not the same. They don't have a common difference. And in like manner, they do not have a common ratio, because 2 times 3 gives you 6, whereas 6 times 2 is what gives you 12. So there's no common ratio in this case. So what we have to do in this case to get our answer is to test these options that are provided to us, and then we'll see which one describes the nth term of the series. So if we test, now I'm going to be testing each of them with term number 2. So going for the first one, where we have 4n minus 2. Now this would imply that this second term would be 4 into 2 minus 2. And this would give us 8 minus 2, and this will give you 6. But if you try that on the third term now, n3 would be, now applying the same thing now, we would have 4 into 3 minus 2. Now check this out. 4 times 3 will give you 12, and 12 minus 2 is 10. So we see that it does not give us the third term. So we continue to try that again. Now we go to the next one. So option A is not correct. Now we try option B. For option B, we have 2 into 3 power of n minus 1. Now, trying with n2, that will imply that we'll have 2 into bracket 3 raised to power, since it's second term, to be 2 minus 1. Now, testing this out, this will give us 2 open bracket 3. And this will give us 6. Yes, we get the second term. Now, let's see third term. For the third term, that will be 2 into 3 minus 1. And that will give you 2 into 3 squared. 3 squared is 9. 9 times 2 will give you 18. So, option B is not correct. Now, option C. Let's test option C. We have n squared plus n. Now, for term number 2, that will imply that we have 2 squared plus 2. And this will give you 4 plus 2, which is 6. Now, n3 will be 3 squared plus 3. And 3 squared is 9. 9 plus 3 is 12. That's correct. Wow. So let's try n4 now. Then we'd have 4 squared plus 3, which is 16 plus 3. N squared is, oh, so this is 4. This should be n. So that is 4. 4 squared is 16. So 16 plus 4, and that will give us 20. Okay, so now we see that option C is the correct one. So we'll go for option C. Now, let's solve this AP question that says the 10th term of an AP is 32. If the first term is 3 over 2, what is the fourth term? Now, in order to find the fourth term, first let's find an equation that connects all of this. So the 10th term, that is T10, will be given as 32 equals first term, which is 3 over 2, plus n minus 1, where n is 10. So 10 minus 1 will give us 9. So 9D. Now this is following off the equations that says nth term of an AP is A plus n minus 1D, right? So working with this, let's make 9D the subject. 9D becomes 32 minus 3 over 2. So we can then go on to say 9D equals, LCM here is 2, right? So this is like over 1. So 1 in 2 is 2. 2 times 32, we have 64. So this will be 64 minus 3 over 2. So 9D becomes 61 over 2, which implies that D is 61 over 9 times 2 is 18. So now that we have the common difference, we can now find the fourth term using this equation. So T4 will be given as first term is still 3 over 2 plus n minus 1. Now n minus 1 means 4 minus 1, and that will give us 3 into common difference, which is 61 over 18. Now 3 here 1, 3 here 6. So what we have here is that T4 becomes 3 over 2 plus 61 over 6. Now taking LCM as 6, 2 here 3, 3 times 3 is 9. So 9 plus 61. 61 plus 9 would give us 70. 70 over 6. Now we can still break this further because 2 goes in both. Now 2 goes here 35 times over 2 here 3. So we have 35 over 3. So the correct option is A. Now this question says if 8, P, Q and 26 is an AP, if it is an AP, find the value of P and Q. Good. So when you look at this kind of question, it's one of those that even without calculating or doing any kind of solving, you can arrive at an answer, right? Because when you look at the options here, you see P is 14, Q is 14, P is 20, Q is 14, P is 20, Q is 20, and then P is 14, Q is 20. Now for this to be an AP, as you can see, we do not have any negative number in the first and the last term that we have here. That tells you that the common difference is going to be positive since the last term is larger than the first term. So it has to be a positive common difference. And if you're adding positive numbers to positive number, it means the number will continue to grow as you go from first term to the last term. So definitely P has to be less than Q. And if you look at the options provided, you will see that P is 14 and Q is 20. And if you check this, the common difference will be 6. So in your answer, you can then go on to say that P is 14 while Q is 20. And check it. Since the common difference is 6, 8 plus 6 will give you 14. 14 plus 6 will give you 20. And 20 plus 6 will give you 26. Now, this question says, if 8, P, Q, and 26 is an AP, find the value of P and Q. Now, when you look at a question like this, especially because of the kind of options you are given in the answers provided, we can see that from this progression that we have here, there are positive numbers. The first term is a positive number, the last term is a positive number. And we can also see that it is increasing since the first term is 8 and the last term here is 26. That tells us that the common difference of this AP is also going to be positive. So we know that P and Q are positive numbers, and we know that Q has to be greater than P. And when we consider the options provided, you would see that it's only option D that satisfies that, where we have P is 14 and Q is 20. And if you check, the common difference here is 6, which implies that when you add 6 to 8, you should get P. And 8 plus 6 will give you 14, just as in option D. And 14 plus 6 will give us 20, just as is in option D as well. And if we say Q is 20, 20 plus 6 will give you the last term, which is 26. But in case you don't have this kind of options, this is how you also solve it. Now take note, we already know the correct answer is D, but this is how it is solved if you are going to show workings. So we can pick any of the term, for example. So looking at the last term here, T4. This is supposed to be following the formula. T4, which is 26, should be A, which is 8, plus is the fourth term, so N will be 4 minus 1, then D. So since we don't know the common difference, let's work with this. So we have 26 equals 8 plus 3D, which implies that 3D equals 26 minus 8, and 3D would give us, now the difference here is 18, so D is 6. So now that we have D as 6, we can then go on to solve for P. So P is actually T2, the second term. And the second term is supposed to be the first term plus common difference, so which is 8 plus 6, and that will give you 14. And then Q is T3, which is actually T2 plus 6, so we would have 14 plus 6, which will give you 20. So P equals 14, while Q is 20. So once again, showing that D is the correct answer. This question says, what is the general term of a sequence? So we have a sequence where the first term is 3, and then the next terms are 8, 13, 18, and so on. So we have to find the general term. That is an equation to find each of the term in this sequence. Now, in this kind of question, what we have to do is to test the options provided. Now, in the first option here, we're going to test 5n minus 2. So for the first term, n1, that is when n is 1, we would have 5 into 1 minus 2. This would give us 5 minus 2, which is 3, which is accurate with the first term. Now let's test for term 2. Now, if we are testing for term 2, we'll have 5 into 2 minus 3. 5 times 2 will give us 10, and 10 minus 2 would give us 8. Also accurate. You can go on to test for 3 just to be sure. And then we'll have 5 into 3 minus 2. Now 5 times 3 will give us 15. And 15 minus 2 would give us 13. Also accurate with term 3. So we see the correct option is A. Now in this question, we're given the third term as well as the 12th term of an AP to be 6 and 12. So now we have to find the sum of the first 12 terms of that AP. So now, working with the fifth term, which is 12, ought to equal the first term A plus n minus 2. Now, n here will be 5, and 5 minus 1 is 4, so 4D. Now, if we call this equation 1, we can apply the same thing now for the third term. Now, the third term is 6. This is equal to A. Now, plus, now third means n is 3, so 3 minus 1 will give us 2, so 2D. This is equation 2. And when we subtract here, we're going to have 6 equals, now this is 0, so 2D. And what this implies is that D equals 6 divided by 2, which will give us 3. Now, using any of the equation, we can then go on to find the value of A. So using the first equation, for example, we can then say 12 equals A plus 4 into 3. So that is A would be 12 minus 4 times 3, that is 12. So A is 0. So now we have our first term and we have our common difference. So now the question itself says we should find the sum of the first 12 terms. So, and S subscript n is supposed to be given as n over 2 into 2a plus n minus 1 d. Now, applying this formula, S of 12 would then be, now n being 12, so 12 divided by 2 will give us 6. 2 times 0 is 0, plus 12 minus 1, that's 11, into d. So what we have here is 6 multiplied by 11. D is, now we've solved d to be 3. So what we have here is 6 times 11 times 3, that's 33. So let's multiply this. 33 times 6. 6 times 3 gives 18. Carry 1. 6 times 3 is 18 again, plus 1, and then we have 19. So what we have here is 198. And that is what we find in option C. This question from Jamb 2023 says, the second term of a GP is negative 2 over 3, and its sum to infinity is 3 over 2. So find its common ratio. Now, a quick hint out there, whenever you're looking for the common ratio of a GP like this, such that the sum to infinity is provided, note this, that you cannot get the sum to infinity of a GP whose common ratio is greater than 0. So it has to be 0 or negative for you to have a sum to infinity. So that tells us that our answer is definitely going to be a negative answer. So from that alone, seeing this question, you can get that your answer is going to be option A. However, let's solve to see how you can arrive at that. Now, sum to infinity of any GP is given as a over 1 minus r, right? And what we have here is the second term. So we have to use this to find the first term. And we know the term of a GP is given as a into r n minus 1, right? Which implies that second term T2 is going to be AR, right? So if the second term is minus 2 over 3, this will equal AR. So working with this, we can make A the subject of this formula. A would be minus 2 over 3r. So now we have an expression for the first term. So we can then impute this into this formula here for sum to infinity. Now the sum to infinity is given as 3 over 2, right? And this would be A. A is negative 2 over 3r divided by 1 minus r. So working with this, we can then have it as 3 over 2 equals minus 2 all over. Now 3r will come down like this, and then we'll have into 1 minus r. Now let's work with this. So this implies that what we have here will be 3 over 2 equals minus 2 all over. Now 3r times this will give us 3r, then minus 3r times r will give us 3r squared. Now let's cross multiply. When we cross multiply at this point, we would have 3 open bracket 3r minus 3r squared, and this will equals 2 into minus 2. Now this will give us 9r minus 9r squared equals minus 4. So let's write this as a quadratic. Taking this here, you have plus now 9r squared. This come here become minus 9r, and then this would remain minus 4 equals 0. Now, let's factorize this. Now, when we do 9 times 4, that will give us 36, right? So we need two numbers that when multiplied will give us 36, but when added would give us 9. So we know that 12 times 3 will give us 36. But because we want negative 36, we'll say minus 12 times 3. That will give us minus 36. And then we say minus 12 plus 3. This will give us minus 9. So it works with what we have here. So we can then go on to write this as 9r squared, right? Minus 12r plus 3r minus 4 equals 0. Now let's group it. Now here, what they have in common is 3r, leaving us with r minus 4. No, that would be 3r rather, minus 4. Now here, they have plus 1 in common, leaving us with 3r minus 4 as well, all equals 0. So what this means is that we have 3r plus 1 equals 0, or 3r minus 4 equals 0. So from here we can say 3r equals 1, which implies that, equals minus 1. So that is r will be minus 1 over 3. Or here we say 3r equals plus 4, which implies that r will be 4 over 3. Now if you observe, we have two answers for r. 4 over 3 is part of the option. Negative 1 over 3 is also part of the options. But what I said from the beginning is that when you're trying to solve for sum to infinity, you can only get sum to infinity of a GP when your common ratio is 0 or less, that is negative numbers, that is less than 0. You cannot work with it when it is greater than 0. So in that case, minus 1 over 3 remains the answer, so we pick option A. Let's solve this question from Jamb 2023. where we are told that the sum to infinity of a GP is 100. And we are to find its first term if the common difference is negative half. Now, sum to infinity of a GP again is given as a over 1 minus r, where a is first term and r is common difference. So since the sum to infinity is given as 100, so 100 will be a, which is what we're actually looking for, all over 1 minus r is minus half. So if we work with this, we should have 100 equals a over 1 plus half. So 100 equals a all over 3 over 2, which implies that a would be 100 times 3 over 2. Now 2 goes here once, 2 goes here 50 times. Now 50 times 3 will give us 150. So the correct option here is option A. This question asks to find the seventh term of the sequence negative 10, 50, minus 250, and so on. So now looking at this, we can tell it's not an arithmetic progression because we move from negative 50 to 50 and then to negative 250. So the next thing to test is to see if it is a GP. And if it's a GP, it should have a common ratio, which should be 50 over minus 10, which is the same thing as negative 250 divided by 50. And both of them are going to give us the same thing, which is negative 5. So that tells us that it's a GP with common ratio negative 5 and first term of negative 10. And the nth term of a GP is given as AR power of n minus 1. Therefore, T7, which is the seventh term in this case, would be A, which is negative 10 into bracket, the common ratio, negative 5, power of n minus 1. So 7 minus 1 will give us 6. Now, when you are working with something like this, you can easily break it down and say this is minus 10 into minus 5 squared, then everything cubed. Because 2 times 3 will still give you 6. This way, what we have is negative 10 into minus 5 squared will give you 25. Now, take note, even the minus is squared in this case. So that's why we have 25. So what we need is 25 cubed. And you can press your calculator for this. And that should give you 15625. Now, if we multiply these two together, we're going to arrive at negative 1, 5. Let me write that. Negative 156,250. So the answer is option C. Now, if you have been following with this series, please ensure you tell as many that are taking the Jamb mathematics exam that they too can ace Jamb mathematics by practicing with just 30 days where they dedicate 30 to 45 minutes of their time daily. I'll see you in the next video.